Welcome back. In today's Byte, you'll learn how to clean your HR analytics data in only 5 steps. Stay tuned. Data cleaning is a key element in HR analytics. Before you can analyze your data, it needs to be clean. In this Byte, I will explain why data cleaning is important and how you can do it. I've also included a link to a helpful in-depth article in the description below, in which you can find a data cleaning infographic to guide you further into the process. Let's now dive into it. A common saying in data analysis is garbage in, garbage out. What this means is that you can put a lot of thought and effort into your data analysis and come up with lots of results. However, these results will mean nothing if the input data is not accurate. In fact, the results may even be harmful as they can misrepresent reality and lead to wrong decision making. HR data is oftentimes dirty. Dirty data is any data record that contains errors, which is something that can happen for various reasons. Data cleaning helps to run a smooth analysis. It also helps normal HR reporting, as clean data can be fed back into the HR systems. This will help improve the data quality and is extremely beneficial for later data analysis and data aggregation efforts, making data cleaning a necessary step in the HR analytics process. Now that you've become familiar with data cleaning caveats, here are 6 practical steps for data cleaning. 1. Always check if the data is up to date. 2. Check for recurring unique identifiers. Some people hold more than one position. Systems often create separate records for each position. These people thus end up having multiple records in a single database, which is a common reason why large organizations have inaccurate headcount numbers. Depending on the situation, these records may be condensed. 3. Count missing values. When missing values are overrepresented in specific parts of the organization, they may skew your results. In addition, an analysis with too many missing values runs the risk of becoming inaccurate, which will impact the generalizability of your results. 4. Check for numerical outliers. Calculate the descriptive statistics and the values of the quantiles. These enable you to calculate potential outliers. The minimum and maximum values are a good starting point, as well as the mode, which is the most frequently occurring value. In addition, you can calculate the interquartile range. If this seems too complicated, don't worry. I'll share with you a link that'll help you in calculating the interquartile range in the video description. Finally, 5. Define valid data output and remove all invalid data values. This is useful for all data. Character data is clearly defined. For example, gender is defined by M or F. These are the valid data values. Any other values are presumed to be invalid. These data can be easily flagged for inspection. In doing so, remember that numeric data is often limited in range. For example, working age is between 15 and 100. And so, numeric data that falls outside the predefined range can be flagged the same way. Creating clean data doesn't stop here. Although it is possible to feed the clean data back into the source systems, the data practices that led to this dirty data will still be in place. This means that newly inputted data will continue to be as dirty as the old data. The only way to fix this is to optimize the systems to ensure future data quality. For more insight into this, check out the link to a very useful global data integrity course that you can find in the video description. That's it for today's Byte, in which you've learned about the importance of data cleaning and how to perform it in 6 steps. If you'd like to get started right away, I included a link into an in-depth article in the video description, in which you can find a data cleaning infographic to help you dive straight into the process. Remember to stay up to date with our learning bytes by subscribing to our channels, and if you like this video, make sure you like and share it, and I'll see you soon in our next learning byte.